Okay, so let us continue with our discussion sa mga reactions. I think we ended with hydrogen displacement yesterday. Sige, wait. Ayan. Sige, we are still under the redox reactions, oxidation and reduction reactions. And then, single replacement na tayo, pero let us concentrate first sa hydrogen displacement. So, this is where we have reactions involving water plus a metal. And if ever the metal is more reactive than hydrogen, then it will replace one hydrogen in water. So just like the examples on the screen, we have there sodium. Pag nilagay natin siya sa water, dinisolve natin siya sa water, what happened there is, ayan, sige, let me illustrate this. We have Na plus HOH. Ilagay natin siya as HOH so that we will see kung saan na hydrogen yung papalitan niya. So in this case, we'll have a more reactive metal, sodium, and it will replace this hydrogen here. This will become NaOH, and then again, hydrogen will be displaced. But if ever na-confuse kayo, isang hydrogen lang yung pinalitan, but ang na-displace is dalawa. Remember our diatomic molecules, the Birchnow. Okay? The Birchnow are our diatomic molecules. These are the elements that if they are not combined with other elements, different element ha, hindi sila combined with another element, they will exist as a diatomic molecule. So always yan siya, may 2 as a subscript. So this will be the equation, and then you just need to balance it. So in this case, this one is the balanced equation. If ever sodium will replace hydrogen in water. So take note, this will happen if you have a more reactive metal. Thus, hydrogen displacement also follow the activity series of metal class. So please, I hope you have your index cards now for the activity series of metal. Just use the one na lithium yung number 1 in the list because lithium is considered the most reactive among our metals. Now, for the example number 2, you have there another reactive, more reactive metal, the calcium. If you place it in water, calcium will replace 1 hydrogen. So pag na-replace niya si 1 hydrogen, you have here Ca plus HOH. This hydrogen here will be replaced. Then you will have CaOH plus, remember, hydrogen is a diatomic molecule. So, bakit may 2 dyan? Kasi calcium belongs to group 2A in the periodic table. Thus, ang charge niyan ay positive 2. And OH is negative 1. It's a polyatomic ion with a charge na negative 1. So if we add the positive and negative charges, this will not be equal to 0. And then, kung hindi siya equal to 0, then we have to do the crisscross. So the hydroxide will have 2 as the subscript. So that is what, ito yung magiging products ng reaction ni calcium again and ni water. So in the laboratory, this is how we do it. Inside a beaker, we will place water, and for beaker letter A, we add there sodium. So again, yung magiging products will be the sodium hydroxide and a hydrogen gas. So you will, syempre gas, you cannot see that, but we have evidences that merong gas formation. So example, yung mga bubbles dyan na nakikita ninyo, again, that will be our evidence that there is a gas na form. So in this case, we have the hydrogen being displaced. That is also true for beaker, letter B, wherein in cold water, we add the calcium. Okay? So, wait lang. Ayan. We have here other examples for the hydrogen displacement. So we have here, for example, zinc. But this time, this is not just with water, but other pa na substances like our acids. If the metal is more reactive than hydrogen, if you look at your index cards for the activity series of metal, then the reaction is possible. So just like example number 1, we have there zinc plus hydrochloric acid. So again, this is not just for water ha, yung hydrogen displacement. Hindi lang siya sa water, pwede siya sa ibang compounds as long as merong hydrogen. And ang ipapalit mo na metal ay mas reactive. So again, we have here zinc plus hydrochloric acid. Since zinc is more reactive than hydrogen in the activity series of metal, then it can replace hydrogen there. So this is what you are going to do. Pagtabi muna natin yung ating symbols and then ma-display si hydrogen. But since as you can see in the screen, meron siyang subscript na 2, always class, always do this. Always check the charges of the elements so that you will have the correct chemical formula. You will know kung kailangan mo ba ng subscript or hindi. So zinc class, remember, is located in the center of the periodic table, which means siya ay isang transition metal. And pag transition metal, the charge is always positive 2. While chlorine belongs to group 7A, it's a halogen, and our halogens, ang kanilang charge ay negative 1. So, since this is not equal to 0, kailangan natin mag-crisscross, kaya dito naging ZnCl2 siya, naging zinc chloride siya. Wala siyang subscript dito for the hydrochloric acid, but in the product, we have the subscript for chlorine. And again, the reason is this one. We have to check their charges. So aside from zinc, magnesium is also more reactive than hydrogen. Thus, if we place magnesium in a hydrochloric acid solution, then there is a possible reaction na mangyayari. Papalitan ngayon ni magnesium si hydrogen, and you will have there the magnesium chloride. And just like the zinc chloride, since magnesium is positive 2, syempre magkakaroon din siya ng subscript here. And hydrogen will be displaced. Now, let us concentrate. Paano naging redox reaction si hydrogen displacement? If you can see, for example, number 1, you have there the oxidation state for zinc is 0. Bakit siya 0? Again, we assign 0 if the element is uncombined or free element siya. Hindi siya nakakombine with other elements. Now, for hydrochloric acid class, this is positive 1. Hydrogen there is positive 1, while chlorine is negative 1. Now, for the products, remember that zinc, if it becomes an ion, or if it is combined with other element, then it will assume an oxidation state of positive 2. While the chlorine remains as negative 1, so kaya hindi na talaga sinulat yung charge ni chlorine kasi hindi siya kasali doon sa redox reaction. While hydrogen that is being displaced becomes 0 now. Ganun na 0 na siya kasi again, hindi na siya nakakombine with other elements even if it is a diatomic molecule. So, si zinc now, from 0, it becomes positive 2. There is an increase in the oxidation state, and that means zinc has been oxidized. So this part here undergoes oxidation. Na-oxidize siya ha kapag nag-increase ang kanyang oxidation. state. So chlorine remains -1, thus it is not really included in the redox reaction. But for hydrogen, from +1 naging 0, there is a reduction in the oxidation number. Thus, this part here is called the reduction. Okay? And then, if you are asked to identify the oxidizing agent and the reducing agent, just like in our quiz, syempre you have to go back sa ating mnemonics na Geroa and Leora. If merong reduction, it means there is a gain in electron. But the one that is reduced is called the oxidizing agent. Therefore, here the oxidizing agent is your hydrochloric acid, while the reducing agent is the one that is being oxidized. So it is here, for example number 1, it's zinc. Okay? I hope it is clear sa inyo now, and alam nyo na mag-determine ng na-oxidize, na-reduce, or ano yung oxidizing agent or reducing agent. You still have questions about this? Any question or clarification? Wala na ba? Always, class, do not forget, after predicting the products of the reaction, always see to it that the reaction is balanced. So we have other examples here of hydrogen displacement that we can do in the laboratory. So for test tube letter A, we have there the iron, but this time this is not water, it is hydrochloric acid. So if iron again is placed in hydrochloric acid, syempre si iron is more reactive, thus it can replace the hydrogen. So let me write the reaction sa screen. So again, for test tube number 1, you have there the iron plus the hydrochloric acid. Again, it's the hydrochloric acid na nagre-react. And then after, madi-displace si hydrogen. So you will have there, this iron na ginamit dito is iron 2. So since iron 2 siya, later I will complete the chemical formula. And then again, hydrogen will be displaced as a diatomic molecule. So in this case, for the test tube, ang ginamit dyan na iron is +2 and chlorine is -1. So you have to do the crisscross. That is why the correct chemical formula here is FeCl2. Ito yung chemical equation for test tube number 1. But take note that this is not yet a balanced equation. Since you have one hydrogen and 1 chlorine in the reactant side, while you have 2 hydrogens and 2 chlorines in the product. So you can add 2 here as the coefficient para maging 2 din si hydrogen, maging 2 din si chlorine. So this time, this is already balanced. Okay? So ito, this one are other examples a while ago. So parehas lang yung reaction niya. And as you can see, kahit pa dito sa test tube number 1, hindi siya masyadong visible, but we have here evidence of the gas formation. And what is that gas? It's the hydrogen being displaced during the reaction. So yun yung, kung mayroon tayong laboratory class, pwede natin sanang gawin for the single displacement or single replacement reaction. So pwede siya hydrogen, but pwede din naman siyang metal displacement. So ito yung ginawa natin sa laboratory last time na single replacement. Most of it is metal displacement actually. That is why we need the activity series of metal. Though hydrogen is included in the list, but that is just for reference para sa hydrogen displacement natin na reaction. So again, the activity series of metal is a list wherein you can see there the most reactive metal to the least reactive metal. And we use that to determine whether a single replacement reaction is possible or not. So again, please follow the one that has lithium as the most reactive element. And for reference, hydrogen is included there because metals such as copper, silver, mercury, platinum, and gold are less reactive than hydrogen, and thus dili siya possible for hydrogen displacement. Tanan metals class nga naa sa taas ni hydrogen can cause hydrogen displacement. But for metal displacement, you have to take note that kailangan yung i-replace mo na element, the element that should replace is more reactive than the original na element. Okay, itong i-replace natin na element should be more reactive than the original element. Paano natin yun malalaman? Dapat ang i-replace natin na metal ay nasa taas ng list ng ating activity series of metal, and that the original element in the compound should be below the element na i-replace natin. Okay, so again, in the activity series of metal, lithium is the most reactive while gold is the least reactive element. So actually, ginagamit ito ng mga scientists ang metal displacement to obtain pure metals from their ores. Kasi yung mga metals natin class, kung sa nature sila, they are actually deposited as minerals sa nature, but they are combined with other elements also. Thus, if they want to obtain a pure one, ang ginagawa nila is nagme-metal displacement sila. So they let class a more reactive metal react with the ore so that ang gusto nilang metal ay madi-displace and makukuha nila as pure metal. So on the screen, you can see there the vanadium oxide. Vanadium is a metal ha. Vanadium oxide. And then if they want to get the vanadium, they will have here the calcium para sa metal displacement. Now, calcium is more reactive than vanadium. So, what will happen? Calcium will replace vanadium here. So, that is why you have calcium oxide na. And again, vanadium is being displaced. By the way, ang oxidation state ni vanadium is +5. Oxygen is -2. That is why nagkaroon ng crisscross dyan. Kaya you have the V2O5. Now, bakit nawala yung 5 and yung 2 na subscript on the product na side? Because vanadium is displaced. It's a single element and it is not included in the diatomic molecule. So, hindi niya kailangan ng subscript na 2. And for calcium oxide, calcium is +2, oxygen is -2. This is equal to 0, so we don't need to do the crisscross. Thus, we don't have the subscript for the product. Okay? So that is how they obtain vanadium from the ores, the ore of vanadium that is deposited in nature. Now, that is similar also to titanium for chloride. If they want to get a pure titanium, they will have magnesium. Magnesium is more reactive than titanium, so it can really replace titanium in the compound. So thus you have there the magnesium chloride. Again, titanium will be displaced. So again, we don't need to copy the subscript here because the subscript will be dependent in the charges of our element. So since ito titanium +4 and chloride -1, Kaya meron kang crisscross and merong subscript dyan. But that is not true in the case of the resulting compound. Pag na-replace na ni magnesium si titanium, since magnesium belongs to group 2A, magiging, positive 2 siya, and then chlorine is still negative 1. So kaya 2 lang class, 2 lang yung subscript ni chloride here for the magnesium chloride. Now all you need to do is to balance the equation. So the balanced equation here is 1 molecule of titanium 4 chloride reacting with 2 molecules of magnesium, and that will result to the displacement of titanium. Tapos meron ka dyang magnesium chloride. So always remember, kailangan ang ipapalit na element ay mass reactive. Kasi pag hindi siya mass reactive, what will happen to the equation? Wala na tayong kailangang products na i-predict, but there will be no reaction. Again, walang magiging reaction. Pag pag less reactive si metal na ipapalit. And then thirdly, for single replacement, this is still for single replacement reaction, but this time halogen displacement. So halogens class are the group 7A elements in the periodic table. They are our anions and they are non-metals. So we don't need the activity series of metal here. But meron pa rin silang sarili nilang table for reactivity, and kung paano sila nakapasunod dyan sa periodic table nyo, ganun din yung pagka-reactive nila. Since fluorine is found sa pinakataas, fluorine is the most reactive halogen, followed by chlorine, bromine, and iodine. But merong 2 dyan because all of them are members of our diatomic molecules. So possible din ito class, ganito yung mangyayari sa ating reaction. So you have there the chlorine, malalaman nyo kung merong halogen displacement. Kasi yung single element ay hindi metal. Instead, it's a halogen. So it might be a chlorine, bromine, iodine, fluorine, chlorine, bromine, or iodine. And then, remember, chlorine is a diatomic molecule. As you can see, may 2 siya. And then you have there the compound. So this is still single replacement class. Single replacement pa rin ito. Kasi you have element plus compound. But instead of replacing the metal, dirita sa ato ang anions. So pareha sila class na halogen. So look at class the element na you want to replace. If it is a metal or a halogen. If it is a halogen just like chlorine, syempre hindi si potassium ang papalitan mo. Instead, it will be bromine. Kaya lang, ang kailangan nating sundin is yung pagkapasunod nila sa periodic table. Now, chlorine is found higher than bromine, it means na mas reactive si chlorine and that the reaction is possible. So, kaya natuloy yung reaction dyan, meron kang K and napalitan na siya ni chlorine. And again, bromine is being displaced. Now, Britchnov. So, BR there is bromine. So, ano gihapon na siya? Diatomic molecules. So, possible ang reaction again because chlorine is more reactive than bromine. So, this is still class A redox reaction because chlorine here is 0. Bromine here is -1. Potassium is +1, kaya wala kang nakikita dyan na subscript. For potassium chloride, wala din kailangan na subscript kasi +1 and -1 silang dalawa. Now, bromine here is being displaced. Hindi na siya nakakombine with other elements. Magiging 0 na siya. So, redox reaction pa rin. Chlorine from 0 becomes -1. Bumaba, class, ang oxidation number. Pag nag-reduce, syempre, automatic, this will be the reduction na part. So potassium is still the same, so that is not part of the redox reaction. But bromine, from -1, naging 0. -1, naging 0. Tumaas ang kanyang oxidation state. Though hindi talaga siya naging positive, but nevertheless, nag-increase. So this will be the oxidation na part. Okay? So redox reaction pa rin yung halogen displacement. The halogen displacement is still under the single replacement reaction. Now, that is also true for the second example. Since chlorine is located higher than the iodine, so chlorine is considered as more reactive. So more reactive siya sa iodine. That is why the reaction is possible. Pwede niyang palitan ngayon si iodine dyan sa equation. So again, this one happens only between halogens. Fluorine, chlorine, bromine, and iodine. Questions so far about this halogen displacement? Wala na ba? May pangutana. We are down to the last one. Sige. This one will be the last type of reaction under the redox reactions. So we have here the disproportionation reaction. Again, disproportionation reaction. So this one again is a special type of redox reaction, and this one is not really under any type of reaction that we discussed in the laboratory. This is a special type of reaction. Hindi siya, may mga disproportionation reaction na pwedeng under sa decomposition, pwede ding under sa combination, but then again, this one is special. Now, what happens sa disproportionation reaction? This reaction involves an element that is both oxidized and reduced in a single equation. Okay? Yung mga na-discuss na natin ng mga elements, 'di ba? Or na mga equation, merong part na nag-reduce, merong part na nag-oxidize. Pagdating sa disproportionation reaction class, the same element ang magre-reduce and mag-oxidize in the equation. So let me give you an example. We have here chlorine. Pag si chlorine, minix natin with water. Again, si chlorine ay na-mixed with water. So this is a special type of reaction. This is not a combination reaction. This is not also a single replacement reaction. And this is not a double displacement reaction. It is supposedly single displacement because you have there an element in the compound. But what really happens between chlorine and water here is meron kang dalawang chlorine, dalawang hydrogen. So this will be distributed. Si chlorine, isang chlorine will be given to one of the hydrogens, and ang isang chlorine ay ibibigay sa another hydrogen, but this time kasama niya si oxygen. So you will have two compounds here as the resulting or the products. Now, paano siya naging disproportionation reaction? Let me write sa screen. We have there class chlorine. Diba? Hindi siya naka-combine with other element, and ang kanyang charge there ay 0. So for hydrogen, this is +1, oxygen is -2. Now, on the product na side, hydrogen here is still +1, chlorine is -1. Okay? And then, for HClO, ganito. Yung tinuro ko sa inyo yesterday, this is an oxoacid. To get class the charge of chlorine there, anong gagawin natin? Diba? This is a neutral molecule. And paano natin i-compute? Diba? You have H plus Cl plus O equals 0. Diba ganito yesterday? And then hydrogen there is still positive 1. And then we are going to compute for the chlorine. And then si oxygen here is still negative 2. So wala tayong i-multiply na kasi wala siyang subscript. And this is equal to 0. So positive 1 plus negative 2, syempre is negative 1 plus the chlorine equals 0. And then para to get the correct oxidation state of chlorine in the hypochlorous acid, ita-transpose natin siya. Pag transpose natin sa kabila, magiging positive 1 siya. So in this case, this is positive 1. So ganito yung disproportionation reaction. Chlorine here becomes negative 1, but another chlorine becomes positive 1. Si hydrogen and si oxygen, hindi naman nagbago ang kanilang charge class. So kay chlorine lang tayo mag-concentrate. So one of the chlorine here becomes negative 1. Bumaba ang kanyang oxidation number, which means this part here is the reduction. Now another chlorine becomes positive 1. In the part of the hypochlorous acid, naging positive 1 siya. So, tumaas ang kanyang oxidation state, which means this chlorine is being oxidized. So, ito yung sinasabi ko na pag sinabing disproportionation reaction, one element in a single equation is being oxidized at the same time reduced. So, si chlorine lang talaga yung na-oxidize, yung chlorine pa rin yung na-reduce. Ganyan yung disproportionation reaction. Questions about the disproportionation reaction? Anyone? Let me give you another example of a disproportionation reaction. This time, we have actually a, let me share ha, para clean na screen. Okay, this one is another example of a disproportionation reaction. We have here the decomposition, sorry. Ayan. Sige. Ayan, decomposition of hydrogen peroxide into 2 molecules of water plus the oxygen gas. So pag nag-decompose daw si hydrogen peroxide. So anong mangyayari? Remember, in hydrogen peroxide, let me change the color of my pen. Oo, Cl lang siya, Mariam. Pag i-ask kayo, binigay sa inyo yung previous na example na equation, and then you will be asked ano yung na-oxidize, ano yung na-reduce. Cl lang talaga, it's the chlorine. Kasi di ba si hydrogen and si oxygen nun ay hindi naman nagbago ang kanilang charge. So this time, another example of the disproportionation reaction is we have hydrogen peroxide. Hydrogen there is positive 1. And please look at the rules natin for the oxidation state. Diba si oxygen is supposedly negative 2. But for the peroxide, it is negative 1. Negative 1 siya dyan. Pag peroxide siya ha, pag peroxide siya, negative 1 siya. Okay? Now here sa hydrogen, sa what you call this, sa water, anong nangyari dito for water? This is still positive 1 for hydrogen, but the oxygen here is negative 2. Kaya nga meron kang subscript dyan na 2. Kasi di ba nag-criss-cross. So merong 2 dyan na subscript. Okay? Now this time, oxygen here is a diatomic molecule and this is 0. class. So as you can see, hydrogen is still the same, but ano ang nag-iba? Si oxygen. We have 2 atoms of oxygen here. Actually, not 4 atoms of oxygen here, but we have oxygen na na-reduce. Bakit siya na-reduce? From -1, naging -2. So there is reduction here. Now, the same element, still oxygen, ang na-oxidize. So this part here is oxidation. Kasi from -1, naging 0 siya. So kaya this one again is a disproportionation. Proportionation reaction, because in one chemical equation, you have one type of element na both na-reduce and na-oxidize. So this is again a special type of a chemical reaction. But yun lang yung tandaan ninyo. Pag merong element na siya lang talaga in an equation, ang both na-reduce and na-oxidize, matik na yon na disproportionation reaction. Okay. Questions? Actually, that is the last slide for this lesson. Questions, class? Baka meron kayong gustong i-clarify, hindi niyo pa masyadong naintindihan sa ating lesson about the chemical equation. Sino pa dito yung nahihirapan mag-balance or mag-predict ng products? Bakit 0 yung charge ni oxygen? Are you referring to my last example, Dave, no? Kane? Mane? Bakit 0 yung charge ni oxygen?
Yes po, ma'am.
Okay, itong oxygen na ito. Because remember, kapag single element, free element, di ba, nasa rule natin yan, kagaya ng mga chlorine kanina, pag hindi na siya nakakombine with other elements, always yan siya 0. Kahit pa diatomic molecule siya. So, kung babalikan natin yung rules natin, remember, wait lang, sana yun? Reactions in aqueous. Okay. Kung babalikan natin yung rules natin, class, saan na nga yun? Ito. Ayan. So, rule number 1, in free elements, that is in the uncombined state, each atom has an oxidation number of 0. So pag hindi daw nakakombine yung ating mga elements with other elements, 0 yung kanyang oxidation state. So thus each atom in our polyatomic ions like the hydrogen, the bromine, the member sa Birchnough, including the oxygen, even if single or diatomic molecule or ang tawag phosphorus na 4 ang iyahang subscript has the same oxidation number. It is still 0 as long as hindi siya nakakombine with other elements. Pag nakakombine lang siya sa sarili niya, matik 0 pa rin. Okay? Did I answer your question?
Yes po, ma'am. Thank you.
Okay. Anything else? Wala na ba?